All right, so on to the next one here. So a little more homework assistance here for you. So I had to find a unique way to get 2.2 number 10 into the PowerPoint slide, but it looks like it's going to work out pretty good here. So 2.2 number 10, let me read it out of the book here first and let you know what it says here. So 2.2 number 10 asks us to, there we go, use the graph of the function of f to find the following values if they exist. All right, so first of all, this is really where we start to get into calculus. The limits, everything in calculus is related to a limit. So if you're talking about calculus 1, we're talking about derivatives, and we start out with a secant line with 2 points, and we make the limit smaller and smaller and smaller and smaller. So we go down closer and closer and closer to 1 point until we get what's called a tangent line. The slope of that tangent line is the derivative of the function at that point. When we get into calculus 2, we do integration, where we take the area underneath the curve. And basically we can do that with rectangles or different shapes. But as we make those rectangles smaller and smaller and smaller and smaller and smaller, they end up taking the shape of the curve, and we can calculate the area under the curve very, very precisely. So you have what's called the derivative and the antiderivative, or the derivative and the integral, however you want to term those. So in this case, we've got a function f of x. And what we're going to do first is we're going to calculate f of 2. So this should be fairly trivial. We find out we're at point 2. Here's point 2. Where is f of x at? Well, we can see it's right here. It's also at point 2. So for 10, f of 2 is 2. It's not up here because it's not defined for 2. So notice there's a filled in dot here. That's where it actually resides. So now this is where it gets interesting, right? What is the limit as x goes to 2 of f of x? So this is that next one here, right here. So the limit as x goes to 2. Well, that's different, because the limit's saying, well, if I approach 2 from this side, I'm allowed to get closer and closer and closer, but never actually get there. Or if I approach it from this side, closer and closer and closer, but never actually be 2. Then what I see is I'm actually approaching the number 4. So the limit as x approaches 2 is actually 4. And then let's do another one here. The next one here says limit as x approaches 4. So the limit as x approaches 4 of f of x. Okay, so 4 is actually right here. So I'm going to approach this thing closer and closer and closer and closer and closer. Never allowed to be it, but I'm going to get closer and closer and closer and closer to it. Well, you can see that that's also 4. The value of the function as I get closer and closer and closer is 4. And then finally, the limit as x approaches 5 of f of x. So limit as x approaches 5. So 5 is right here. If I go up a little ways, I think it's right here. All right. So as it approaches 5, it's getting closer and closer from here and from above. It's getting closer and closer, but it's getting closer and closer to this value, which is 2. So that's 2.2 number 10.